Video on section 4.2. Um, so, continuing with section 4.2, we'd like to now look at some properties of logarithms and also some common logarithms. So, properties of logarithms. And common logarithms. Log to the base b of 1 is equal to 0. Log to the base b of b is equal to 1. And log to the base b of bx is equal to x, and b to the power of log to the base b of x is equal to x. Log to the So when common logarithms, we don't write the base. So for example, log base 10 of 1, we don't write the 10, so this is equal to 0. Log to the base 10 of 10 is equal to 1. Log 10 power x is equal to x, and 10 log x is equal to x. All right. So these are the properties of logarithms and their corresponding common logarithms, which are all to the base 10, which we don't write. So the next thing, let's look at some natural logarithms. Some natural logarithms. So the function f of x is equal to the log to the base e log to the base e of x is expressed usually expressed as f of x is equal to the log of x. So the log to the base e of x is expressed as ln of x, and we call this the natural logarithm. So log to the base e is a natural logarithm, which we write as ln of x. And so properties of natural logarithms. Properties of natural logarithms. So let's look at some general properties. And common properties. So log to the base b of 1 is equal to 0, and log to the base b of b is equal to 1. is equal to x. And let the now rather b and b power log the base b of x is equal to x, and their corresponding natural form, common logarithm. So this is log of 1 is equal to 0, log of e equal to 1, and log of ln of e power x is equal to x, and e power log of x is equal to x. All right, so with this, we can look at some examples where we would make use of some of these properties. So this will be our example now. So example now, it says when the outside when the outside air temperature is anywhere from 72 degrees to 96 degrees Fahrenheit. The temperature in an enclosed vehicle climbs by 43 degrees in the first hour. In the first hour, the function f of x is equal to 13.4 log of x minus 11.6 models the temperature increase f of x in degrees Fahrenheit. After x minutes. Use the function. Use the function to find the temperature. Also find the temperature increase. The nearest degree. after 30 minutes. All right, so the function f of x is equal to 13.4 natural log of x minus 11.6, and x um, is the number of minutes, right? Uh, X is the number of minutes. So when we need to find the temperature after 30 minutes, so that would mean we have to find f of 30, f of 30. And so that would be equal to 13.4 natural log of 30 minus 11.6. And if we evaluate this on our calculator, we will get approximately 34 degrees. So the temperature increase will be about 34 degrees Fahrenheit after 30 minutes. All right, so let's look at the next example. So this will be our 10th example. So this is example 10. Example 10. And this is evaluate the expression evaluate the expression without using a calculator. So the expression is log to the base of 5 and log to the base of 232. All right, so log to the base of 232. So this is the same as log to the base 5. And log to the base 2 and 32 is the same as 2 power 5. And from the properties of log, we know this becomes log 5 and 5 log to the base 2 of 2, and log to the base 2 of 2 1. So this becomes log to the base 5 of 5, and log to the base 5 of 5 is also equal to 1. So this is how we evaluate this expression without a calculator. So let's look at our last example, which will be example 11. And it says without using a calculator, without using a calculator, without using a calculator, find the exact value, find the exact value of the following expression. All right, so this is log to the base 3 of 81 minus log to the base I of 1 divided by log to the uh, base of 4 root 2 of 2 minus log of 0.1. All right, so log to the base 3, the 1 is the same as log to the base 3, the 1 is the same as 3 power 4, and minus log to the base pi of 1 divided by log to the base 4 root 2, and 32 can be expressed as, so 32 is equal to 16 times 2. All right, so um, and 32 itself is the same thing as square root of 32 squared, right? And this is equal to square root of 16 times 2 all squared. And this is also equal to uh, square root of 16 root of 2 all squared. Right? So this is also equal to square root of 16 is 4. So this is equal to 4 square root of 2 all squared. So we can write um, log of 4 root 232 as log to the 4 root 2, and 32 is the same as 4 square root of 2 squared. All right, so if we substitute this in here, so we have 4 log to the base 3, and log to any base of 1 is 0. So this is 0 divided by log to the base log to the base of 4 root 2 of 4 root 2 squared minus log of 0.1 is the same as, when we don't write the base, is the same as it has a base of 10. And 0.1 is the same as 1 divided by 10, which is also the same as 10 power negative 1. So this gives us 4 minus 0 divided by 2 log 4 root 2, and 4 and 4 root 2 times 4 root 2 here, and minus um, log base 10 of 10 minus log to the base 10 of 10. So the minus 1 comes in front of the log. So this becomes 4 minus 0, or let me just write 4. This becomes 4 divided by 2 minus, um, so this becomes 10 power. So there was a negative here already. So there was a negative here already. So this is, let me write this well. So there was a negative here already. So minus and minus log 10 of 10. And so this becomes 4 divided by 2 minus -1, which is 4 divided by 3. So this becomes our final answer. So this brings us to the end of our continuing and 4.2. So I'll see you in the next section, 4.3. Bye bye.